Good afternoon, grade fours. So today I wanted to take a quick review of what we've done so far in the last couple weeks, and then we're going to go on to something else that sort of uses a couple of things we've covered so far to do some sort of show you a little bit of a mental math trick with larger numbers. Okay, so basically what we started off with, basically math multiplication facts. I showed you how to maybe some tricks on how to memorize those multiplication facts. Hopefully those are going okay. We talked about fact families and the way that you could go 3 times 2 equals 6, which also can be written as 2 times 3 equals 6. And then you can also do 6 divided by 3 equals 2 and 6 divided by 2 equals 3. We talked about these two big words, commutative and distributive principles, which are basically the idea that you can go 3 times 2 equals 6, which also is the same as 2 times 3. And you can also do things like break up larger numbers, like, for example, 13 times 4 can be written as 10 times 4 and 3 times 4, and you take those answers and add them together, and you get the same answer as 13 times 4. And then the fourth thing we did is we multiplied by 10, 100, and 1,000. And then we looked at halving and doubling the other day. So today we're going to take a look at two of these. We're going to look at multiplication facts and also multiplying by 10, 100, and 1,000. So let's take a simple example. Let's take a look at 7 times 4. So 7 times 4, is equal to 28. So that's just one on our multiplication chart. And the other day we also did multiplication by tens, hundreds, and thousands. Well, if I look at 7 times 100, that's equal to 700. But what if I wanted to actually combine the 4 and the 100? What would that do to our answer? So say we wanted to actually do 7 times 400. How would that work? Well, we know 7 times 4 is 28, and we know that we do 7 times 100. I take those two zeros and stick them on the end. So we're going to combine these pieces of knowledge, that 7 times 4 is 28, and when you multiply by a number like 100 or a 10 or 1,000, you just take the zeros and stick them on the end. Well, in this question, 7 times 400, you're basically doing those two strategies in one question. And this is sort of what it looks like. If I go 7 times 400, I do the 7 times 4 first, which gives me my 28. And then I take my two zeros and stick them on the end here. So the answer to 7 times 400 is actually 2,800. It's a combination of these two things. So let's try to take a look at what that might look like if I draw it out a little more. So 7 times 4 is 28. 7 times 40 is 280. 7 times 400 is 2,800. So it's my two zeros, it's my two zeros, my 1 0, my 1 0. So you can see the pattern here, the growth pattern, 28, 280, 2,800. You can probably guess what 7 times 4,000 would be. There'd be one more zero, right? So let's take some examples. Oh, sorry. Before we do examples, this is basically the concept of the rule or the strategy as best as I could sort of summarize it so that it sort of makes sense. Anyway, it says when you're multiplying by a number that ends in zeros, you multiply as if the zeros aren't there and then add the zeros at the end of the answer you get. So I'm going to think of this as 7 times 4 is 28. Just take those zeros, stick them on the end, 2,800. So let's look at some other examples. So 5 times 8 we know is 40 using our multiplication chart if you're not sure, which means 5 times 80, well, there's my 40, but I'm going to stick my 0 on the end. Now this is funky looking because I got two zeros. There's only 1 0 here, but remember the 40 comes from this answer here. So that 0 is in the original multiplication question. So I got my 40, I've added my 0 on. Here, 5 times 8 is 40, plus I have two zeros on. Once again, you can see the pattern, one more 0 each time. 3 times 5 is 15. 3 times 50 is my 15 plus my 0. And 3 times 500 is my 15 plus my two zeros. So you can see how that works, right? There's a clear pattern there. So what happens if I don't use the pattern? Let's jump around and see how this works. So 6 times 3 is 18. I have two zeros here. So those two zeros are going to be put in my answer. I have 5 times 20. 5 times 2 is 10. Plus I'm going to throw my other 0 in here. There's my 0. And 8 times 4 is 32, plus I add my 2 zeros on the end there. All right, so that's basically this concept. It's actually a really neat strategy that I even use still today when I'm doing math or I'm trying to calculate something. If I'm at the grocery store and trying to figure out how much stuff costs, or I'm doing sort of some taxes, work on my taxes or something, I'll often use this strategy. It's a great mental math strategy for multiplying fairly large numbers. So the work I'm going to give you today is actually from your textbook. And the textbook actually does stuff very similar to what I've done here. You're going to be completing a couple of these like this. So, but math is tricky to do on the computer, right? Because it's you have to really write it on a pencil with pencil and paper. So what I thought I would do is I'm including a picture of your textbook, and the questions that I want you to do are circled, and then what I want you to do is you can either write them out and then take a picture of what you've written on paper and send it to me in Google Classroom, submit that as a file, or you can write your answers in work on a Google Doc and submit it that way. I think that would probably be easiest. Anyway, that is the end of the lesson for math today, and enjoy the rest of your day. And by the way, tomorrow, video conference. I hope everybody's on board with that. And I think I said 10 o'clock video conference. We're going to play a game, and I'm going to answer any questions if you have any questions related to what we've been doing in math. Enjoy the rest of your day.